that would look like.
There we go. So it's a leukocyte, it's a white blood cell.
Did you just say, you just kept saying everything was white blood cell, white blood cell?
Did I?
Yeah, red blood cell?
Okay, so I'll get back to this. Okay, red blood cells. Actually, sorry, I've been off this one. Sorry. So red blood cells, all these red blood cells, and then we have a leukocyte right in the middle. Now, you'll look at the cytoplasm is a bit granular. So that's it's a granulocyte, or it has. When you look at the lobe, it looks multi-lobe. So this is a neutrophil. So it looks kind of funky, weird looking. That's one nucleus, but it's said to be multi-lobe. So that's a neutrophil. So more specifically, that's a neutrophil. Sorry, red blood cells all over the page. So, does that really have a large nucleus? Yes. Is it multi-lobe?
Yeah.
No. So that's a lymphocyte. We have a lymphocyte here. We have a neutrophil. So that's a neutrophil up there. Neutrophil. And lymphocyte.
So those are like they're all lymphocytes, the small ones.
Just that one. Just that one. is a lymphocyte. All these are red blood cells, red blood cell, red blood cell. That's a lymphocyte right there.
Alright. Oh. Too fast.
So what's this? Neutrophil or lymphocyte?
Neutrophil.
What's this?
Lymphocytes.
This giant monocyte. See how it's really big? That's a monocyte. Monocyte,
Okay.
neutrophil, lymphocyte.
Whoa.
Yeah. This is squash and weird. I don't know what that is. But that's neutrophil.
Wait, Brian, which one is the lava lamp again?
The neutrophil.
Okay.
Yeah, there's the neutrophil. So here, this is really nice. Neutrophil next to lymphocyte. There they are. We'll compare them. It's cool when you see them next to each other. There they are. Ah. Down there. So here we have neutrophil. See the weird nucleus? Monocyte. And then red blood cells. Erythrocytes. We can't see a monocyte.
So it's a lymphocyte.
Right. Lymphocyte?
I would say granular.
Lymphocyte?
Right.
Neutrophil. We can't see monocytes.
You said monocyte first.
Wait, we can't see lymphocytes?
Neutrophils.
Yeah.
Lymphocyte.
Lymphocyte.
Or erythrocyte. Platelet. Or thrombocyte. Up there, the arrow, yeah, there's that little speck.
The little speck.
So we're just seeing,
We did see that.
oh, so what's that? Is that a?
That's a neutrophil.
Neutrophil. That's a splatocyte. Yeah, so really the most common things for the white blood cells, what you're going to be seeing, the most common will be neutrophils and lymphocytes. Occasionally you might see a monocyte. A monocyte is just going to be really large. Be almost twice the diameter of a red blood cell.
Wait, why are some of them like spiky side?
That's weird. That's
Yeah.
not supposed to be there, so don't worry about that. We'll look at a different slide. It's supposed to be like that. So that's,
You can get at least dye the color for
and
it.
this is,
Stuff is hidden.
yeah, this is normal blood. This is healthy blood.
Anything that's not red blood cells.
The next one, this is kind of weird. Where it's African sleeping disease, what happens is mosquitoes, no, it bites you and infects you, and this trypanosoma, this organism, this trypanosoma, gets into your blood and actually moves around in your blood.
Ew.
Yeah, you see those squiggles? Those, like, little worms in the blood. And it's not too much of an issue until it gets to your brain. You guys can cross the blood-brain barrier. So they get into your brain and they make you very drowsy and very sleepy to the point where you die. So this is not healthy blood.
Yeah, what is it? What is the actual, what is it? Is it?
Trypanosome, it's a, yeah, it's not a bacterium, it's
Parasitic.
What's it called?
Trypanosome.
Oh, trypanosoma?
yeah.
Oh,
It's
okay.
just, yeah, like a microorganism.
It's a
Parasite.
yeah.
Class of organisms.
It's a living one.
It's a monophyletic, unicellular,
It's an evolution class. You've
flagellate,
seen monophyletic.
protozoa. It's a parasitic protozoa.
Protozoan, it's a protozoan.
See,
That's
that's
what,
right.
that's, yeah. It's called, it's some sort of, protozoan that kind of swims around and, yeah, not good. I don't know. There's medication for it. So, yeah. But the best treatment is, bug spray. Yeah,
Well, it doesn't help.
Brian,
Yes.
where do they come from?
It's a fly called the tsetse fly, TSI.
The seats in.
It's hard to say.
The seats.
But you probably notice an elevated level of lymphocytes. So why would you see a lot of lymphocytes? So you'll see, yeah. So that's trypanosoma protozoa. So that's hemoglobin. There's 4 parts. There's 2 alpha, 2 beta units. What happens with the with hemoglobin is 2 of those, I believe it's the beta units, are misshapen. There's one mutate. There's one place of mutation. It's like a G instead of a C, whatever. That's all it takes. And the protein's all misshapen, and it can't bind well to oxygen. So it can only bind 50% because 2 of those alpha. So instead of binding to 4 molecules of oxygen, it only to 2. So you have reduced oxygen. So that's why it's anemia. Also, because it's misshapen, it makes the blood cell a bit wonky. It's not nice and round. It's sometimes sickle shell shaped, or it's just weird. The problem with that is you think about a capillary bed. What's the diameter of a capillary? 1 red blood cell. And they need to line up nice, like a row of Mentos. You know, they just line up really nice. What happens is you get an odd shaped one that messes up the flow and causes blockage, and you get issues. So, and it's painful, it's actually you can become big. So we'll try to, and not all the red blood cells will be sickle shaped, and they're just going to be oddly shaped. Look at that one right there. So you just see a few of them. They just don't look quite right. So you see some wonky shaped red blood cells here, here, here. And you can see, if they were going through a capillary bed or a capillary, it would just, the flow would be obstructed. And it's painful, it causes pain, and so it's that. Again, neutrophil, another neutrophil there. But there's, so if you're homozygous for this trait, you're likely going to die. But if you're heterozygous, so you have a copy, so it's, if you're heterozygous, not all your red blood cells will be misshapen, just some of them will be. There's a benefit for this. If you are heterozygous for this trait, you are immune to malaria.
Isn't it
That's
malaria?
why this trait has remained in Africa where malaria originated. So people that were heterozygous for this had a selective advantage. So this mutation, even though it's deleterious as a homozygous, is beneficial in that environment for a heterozygous. That's why it remained, it was selected for in Africa. That's why this disease tends to be more common amongst African Americans because of that. So it's an interesting story and study in for population genetics, how a deleterious mutation can be selected for because it's advantageous as a heterozygous. Yeah.
Wouldn't like a capillary maybe have gotten a wider diameter through natural selection instead of?
Well, see, the problem with having a wider diameter capillary is it's going to decrease diffusion rate. So it's all about diffusion. So you get, so that's, yeah. So it's kind of, that's sickle cell anemia.
Is it recessive or dominant?
It's recessive.
Interesting. Made it seem like it was dominant.
Or is it co-dominant? Because, yeah, it's not a pure recessive because as a heterozygote, you still end up with some sickle cell misshapen ones. So it's not a clear case of recessive.
We should have just written it.
So that's sickle cell. So for sickle cell anemia, look for the misshapen, weird red blood cells.
It says it's autosomal recessive.
Yeah, it's on the autosomes. It's not on the X or the Y.
Okay.
Yeah. So it's an autosome. And it's a point mutation. It's just one nucleotide chain. It's all it takes for that one unit to be misshapen so that it can't bind to oxygen. And it causes the whole cell also just to be oddly shaped. So yeah, it's just one point mutation.
So that's recessive then.
Yeah,
This next one, here it is. So this is called erythroblastosis fetalis. So erythro, E-R-Y-T-H-R-O, blastosis, and then another word, fetalis, meaning it's in the fetus. Not fatalis, but fetalis. So erythro, you know that's going to refer to erythrocytes or red blood cells. Blastosis means the destruction of yeah, this has to do with the RH factor. So what's going to happen is, if the mother is RH negative, and the mother gets pregnant and she has an RH positive baby, not a problem because the blood does not pass across the membrane, the placenta. Antibodies do, or antigens they do, but the blood itself can't. However, during childbirth, the mother is exposed to these antigens, and she's like, oh shoot. So she makes antibodies, she stores them, she waits. So, and there's that memory, that stored memory of whenever, so if the next baby, any other successive baby that is RH positive, the mother's immune system will attack and destroy those red blood cells. So, and that's what's happening here. These should look there's treatments for this to suppress this immune response. So it's treatable now, you don't even think of it, and doctors do it, it's standard right now, but I guess hundreds of years ago, this was not done, so a lot of people died of this. That's, erythroblastosis fetalis, not fetalis, it's like, and the last one is just gonna be bone marrow. This is the site where blood is made. So, the production of blood is hemopoiesis. So the production of blood, hemopoiesis, but more specifically, if we're talking about red blood cells, it would be erythropoiesis. For white blood cells, it would be leukophoresis. So we have lots of blobs of fat. That's the yellow marrow. The red marrow, all in here is where the blood is actually made. And this is only in really such bones as the femurs, the really large, longer bones, and maybe ossa. It's only the larger bones, not the small bones. So, again, we can see a lot of the red marrow. This is where white blood cells and red blood cells. Oh, there it is. That's a megakaryocyte. It's mega. It's huge. So these are blobs of fat. Let's call that. That's a megakaryocyte, and there's another megakaryocyte. These are the structures that break apart and become thrombocytes or platelets. Mixed in here are red blood cells and white blood cells. In this slide, you can see pinks and purples. The pinks will be red blood cells, the purples will be white blood cells. True or false, in the field of view, you can see red blood cells with nuclei.
False. They don't have nuclei.
But in this,
Which nuclei, true?
yeah, so in here we have erythropoiesis is occurring. So some of them are maturing, so there are some immature red blood cells in here. So here we will see them. We can see that there are some. So that's a bit of a twist. So that's how the questions are going to be phrased on the exam. Is in the field of view, you can see yellow marrow.
True.
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 In the field of view, you can see the site of hemopoiesis.
True.
Yeah.
It's just red marrow, right? Like
Red and yellow. So
fibrosis.
you see red and yellow. I'm trying to come up with a false statement.
In the field where you can see monocytes.
Well, yeah, I mean, yeah, so.
In the field where you can see astrocytes. In the field where you can see astrocytes.
Okay, so yeah, this is bone marrow. And that's it for the histology,
Okay.
for this unit.